Hello everybody, my name is David Wetz and I am a professor in the electrical engineering department, and I help organize, along with a team of folks who help make it possible, our college's Innovation Day. As you know, this year we have gone virtual with it, as we did last year, kind of reacting to the pandemic. The first couple years we did it in person. Hopefully next year we'll do it in person along with this hybrid approach, a virtual approach as well. But we've had some amazing participation from our students this year, and we are so proud and thankful for all that they've done. And hopefully today we can showcase some of them with some awards. I'm going to go to the next slide, Mr. Igor. So just kind of as a start, thank you to all of our participants, our advisors, our sponsors, and our judges. You guys have responded, as I've said, amazingly with dealing with the pandemic. This year we had 119 total projects submitted. That makes up over 500 students who have participated either at the undergraduate or graduate level, kind of combined. A lot of them did some as part of classes with senior design, some of them were extracurricular with REU, and then of course graduate as part of their graduate research. So thank you to everybody who participated. We had 20 industry financial sponsors, most of which have been with us ever since we started Innovation Day 4 years ago, but quite a few new ones as well. There are no words to say thank you enough to them for all they do. Without them, this would not be as successful. So on behalf of our students, our faculty, everybody, thank you for everything that you guys have done. There were 14 industry sponsors of our senior design projects. So you'll see some of those if you go to the website. You can take a look at those. And then we had 115 judges. Because of the virtual nature of this, we've been able to reach out to alumni and industry sponsors from around the world. I believe we have 4 or 5 different countries represented of people who are overseas viewing these presentations and helping us. So thank you to them. Clearly, as you get into different time zones and whatnot, it becomes a challenge. So thank you for your commitment to our students. Next slide. Sponsors. So as I mentioned, we had roughly 20 sponsors. These are them at the different levels that they helped contribute. In a minute, you'll see Raytheon is our platinum sponsor, and there are no words to thank all of our sponsors, but especially Raytheon enough for everything they've done. In addition to supporting Innovation Day, they are also a senior design sponsor and have done an amazing job with students in electrical engineering, computer science engineering, and mechanical engineering over the last several years. And so in a minute, we'll have kind of a little bit of a keynote presentation from Mr. Jesse Lee from Raytheon, and we'll get to that in just a second. But again, thanks to all of our sponsors, so many of which have been with us since the beginning, so thank you to them. Next slide. And these are the senior design sponsors. You know, many of these are financial sponsors, many of these are just mentor and support sponsors. But regardless, we're so thankful for everything they do for our students as far as mentoring them through kind of real life projects in senior design. So thank you to them. Next slide. So as I mentioned, Mr. Jesse Lee is at Raytheon here in Plano area. They work in the information securities division of Raytheon, doing a lot of cool things, kind of keeping information safe. And so I will turn it over to Mr. Jesse Lee, who is a graduate of Texas Tech University, and he will kind of give you a little bit of information on Raytheon and some of the work that we're all collaborating on.
Thanks, Dr. Wetz. My name is Jesse Lee, and officially I'm a cyber architect for Raytheon on the front end of the business side. I've been in cyber for about 20 years, and I have had the pleasure of being able to be a Raytheon University representative specifically for UTA. We've always received real high quality work from UTA, and the collaboration is great. The hospitality goes beyond without words. So it's a real pleasure to be working with UTA. We've been doing sponsorship, I think, since 2016. One of our employees was also getting his bachelor's degree there, and we sponsored undergraduate projects there. He did an innovative challenge of his own, and ended up getting one patent with 4 provisions from it. So we're real excited to see what UTA has had to offer, universities in general, but specifically UTA, and we're a big proponent of the Innovation Day that you guys do. I wanted to also share with you corporate value with respect to how we see this working with Raytheon as we sponsor the innovation. Raytheon looks at this as a really long interview process, and we're able to see the quality of individuals that come out of the program, see how they've grown over the year. We're able to see how people interact, and so we look at this as the ability to really do a long interview process and interact with the students. We also use it as a platform for early entry into the program, and this is a new thing that Raytheon has started doing, but in doing so, it allows us to move forward something that it ends up taking a rather long process once a student graduates and gets into the company. So we get to immerse them into Raytheon's culture and atmosphere and how we do things, and it offers training on the front end for the students as well. So for student value, we love this because we're introducing you to real world problems, requirements definition and refinement, design, budgeting, scheduling, team creation, the structure and dynamics of the teams, and then the management of the team as well. Program management in general, implementation, problem solving, testing, and then finally production. And how this is being realized this year is we're sponsoring the first ever Raytheon Innovation Challenge. We're super excited about it. At the undergraduate level, we've asked 3 different universities to, well, compete is a strong word, to enter into 3 different challenges within the vignette that we provided. And Dr. Wett's UTA and the facility has allowed us to go onto the football field. This will happen next week. Go onto the football field, and we're going to have 3 different challenges from 3 different universities to implement automation drone flight. What this looks like when it's actually played out is we've got one innovation challenge where it's distance based on accuracy, and the distance can be implemented in several different ways. We left it really open-ended in order for the various different teams to exercise their innovative thinking and implementation and challenges. The second one is to find a random landing spot. We've offered them the ability to know what that landing spot looks like, but that the teams each have to find that landing spot and then land on it. And then finally, we're doing a challenge where it's finding the landing spot while avoiding obstacles. And when we first started this, we thought, hey, these are probably pretty easy to accomplish. And what we found out is when you're starting from ground zero, this is actually a lot harder than one would think. And you add in team dynamics, and you add in 3 different teams trying to coordinate and build something together. And it's a real difficult challenge. What Raytheon loves about it is that it's real world. This is exactly what we experience in the real world. We're constantly collaborating with we call them competimates, people that we compete against, and also they're our teammates. And we're constantly working together to try and achieve a single mission. So Innovation Day, the program in and of itself at UTA, we are huge proponents of. We're really thankful that we can be a part of it, and we're super stoked about May 1st coming up for the first Raytheon Innovation Challenge. So thank you guys, and love what y'all are doing, and keep it up.
Thank you, Jesse. Thanks for all you do. We appreciate it more than you know. And for those of you who would like to attend next week, we're trying to keep attendance somewhat limited, but if any students are interested in attending that next week, it will be at Maverick Stadium on Saturday. I think we're going to start somewhere between 8 and 9 in the morning, and we are allowed to have some visitors as long as there are some attendees, as long as everybody's willing to wear their mask and maintain social distancing. We'd love to have students out there supporting our students. So thanks again, Jesse. We appreciate it.
Thank you.
All right, next slide, Mr. Agor. We can All right, so we are going to start with the awards for the research experiences for undergraduates. Before I get to them, clearly you can see their names there already. Congrats to them. Before I do this, I do want to recognize that there are 4 people who really make this event all possible. You wouldn't believe the work that goes on behind the scenes from Mr. Jeremy Agor, Ms. Tracy Falkenberry, Mr. Chris Wood, and from Dr. Lynn Peterson. Dr. Peterson helps more than you know with organizing all the judges. There's a lot of work that goes into getting judges lined up to give these awards. Jeremy and Chris help like you wouldn't know to get all the abstracts and the book and the website up, and so we're so grateful to them. And then of course Tracy is the glue that holds all of us together. So thank you to all of them, and I hope you guys know how much they care about you and enjoy seeing your success. So on to the first place award winner. Is a group of students who are participating on a project that they call Autonomous Vehicle Meets 3D Printer, Cost-Effective Monitoring of Additive Manufacturing Using Robots. And the students are Travis Major, John Smith, and Cindy Cruz. Their advisor is Dr. Chen Kan. And I believe that John is on to tell us a little bit about their project. We're going to ask each group has one representative that's going to kind of give us a quick 2 to 3 minute overview of their project. So that we can all kind of learn a little bit more.
Yes, I'm here. I can get the PowerPoint pulled up. Our project, as he stated, was the Autonomous Vehicle Meets 3D Printer, Cost-Effective for Monitoring of Additive Manufacturing Using Robots. This is brought to you by Travis Major, myself, John Smith, and Cindy Cruz. A little bit of background on this situation. The additive manufacturing process is widely used across the manufacturing industry. This is 3D printing and creating objects essentially from nothing. There's problems in the process where inherent issues create defects with the machines causing problems and sometimes the environment itself. This necessitates regular monitoring of the process. Currently, the setup that's used is a 1-to-1 ratio of machines to cameras. You can see that in the right-hand side. The problems with this is it creates a large data stream. It's computationally expensive, and it's very cost prohibitive to scale up to 3D printing shops that we want to see with 60, 80, or 100 3D printers operating simultaneously. Our experimental setup in this process and a potential solution is to use an autonomous car with a sensing device on top or associated that can in real time transmit data back to a machine learning software on a computer server somewhere that can then implement quality assessment and control commands back to the car and the printer on the shop floor. This will allow us to scale up to potentially any size of solution and shop floor. What we used to do this was the UTA race car on the left. This is an autonomous vehicle. It operates fully autonomous. It's built on the MIT race car platform, and it pulls along a 3D printed and fully custom camera mount that uses Arduino, a Logitech StreamCam, and a stepper motor to adjust the height. You can see here the vehicle pulling up to the sensor, following the track, and stopping at the predetermined position. Once the trailer comes to a complete stop, it senses and communicates with the printer to find the current bed level, initiates a homing procedure, and then goes to the exact level of the printer currently. From there, the computers take over and the camera collects images that are put into a neural network and machine learning software is used. We used a VGG16 neural network trained with 6,445 video frames. We measured accuracy, sensitivity, and specificity to guarantee our performance measures. Once this is completed, the car will move along the track and go to the next printer or printers in its determined area. The model was trained using 3 specific parts. On the left, you have the good part, then the common layer shift defect, and then the ever unfortunate spaghetti defect. Those images on the top row were used on our RGB neural network where color was left in. They were also converted to binary image, which is the ones on the bottom, and analyzed in that way as well. Our models were able to achieve 84 to 98% accuracy on the normal versus layer shift parts and 100% accuracy across the board on the normal versus spaghetti parts. Our team would like to thank our industry sponsors and partners that have been able to come today. We'd like to thank the College of Engineering and Innovation Day for being put on, the Research Experience for Undergrads program, and our faculty advisors, Dr. Chen Kan, Jin Nu, and Yuan Zhao. Thank you very much.
Way to go, guys. That's great work. Very cool. There's another robotics competition I'd like to talk to you about that I think this would fit really well into happening over the summer. So I will reach out to that and like to see that go further.
Yeah, absolutely. We'd appreciate it.
Okay, Mr. Agor, do you want to go back to the slides? Maybe. All right. So our second place is a electrical engineering project, and that is remote sensing of subsurface soil moisture. We have a rather large group here of Tongwyn, Susav Shrestha, Beatrice Meadows, Nicholas Jennings, and Easton Bryan, and I believe that Tone is going to be presenting for us today. Congratulations, guys.
Thank you, Dr. West. Hello and good afternoon, everyone. It is an honor to be here today to represent my team. My name is Tongwyn, and our project is the remote sensing of the subsurface soil moisture. And we all know that over the past decade, the need for the soil sensing has become increasingly important due to climate change. Natural disasters such as wildfire and flood have occurred more and more frequently. And in those times, different methods of soil sensing were proposed and implemented over the time. However, each of them has their own advantages and disadvantages. So our goal of this project is to study a possibility of the new soil sensing system, which could combine the strength and disregard the weaknesses. Our end goal is to create a system that could sense the soil moisture wirelessly, and we could scale it up to cover a wide range of area. Our proposed system consists of three main components, which is a sensor that stays on the ground, a radar system that could send and read back the signal from the sensor, and an inversion algorithm that could analyze the reflected signal. As of now, we have finalized the design and fabricated this soil sensor and the radar system. In the future, we'll plan to take in the measurement as well as developing the inversion algorithm. We hope that this project could contribute to our fight against climate change. And for this, I want to express my gratitude to our faculty advisor, Dr. Twacher, for his incredible support and patience over the past year. And I also want to give special thanks to my teammate, Susav, Monse, Easton, and Nicholas. This achievement is possible because of your help. And once again, thank you everyone for being here today. I hope you all have a great day.
Way to go, Tone Group. We appreciate it. Great job. We're very proud of you. I know Dr. Twacha is as well. Okay, so our third place winner is a project using augmented reality and machine learning to guide physical exercise robots, and that is a group of one, which is pretty cool in REU. Kyle Henry, and the advisor is Christoph, I should know this, but Solner. So I will turn it over to Kyle.
Yes, hello. It's an honor to be here. The first innovation I've actually been to was actually my freshman year of high school, so love how this wraps around. But anyway, get to the point. So the project that I'm showing to you today, it's basically an augmented reality app that seniors 65 and older are going to use later on in project development for exercising. And the point of exercising is not just to get in the best shape or whatever. It's just to keep them motivated, keep them going, keep them in a positive attitude. Because as medicine and technology develops, we're going to live longer lives. But the thing is that even though we might be physically fit, that doesn't necessarily mean we're mentally fit. And as you get older, you start to lose people, you start to lose connections, and we just want to make sure that that doesn't happen. So we're making this app to make a difference. All right. And I'm about to share my screen. I'm going to go ahead and demo the app, both the Android and iOS version of the app, so you can see the difference in computation. All right. Can y'all see?
Yes.
All right. Okay. So what I have here is this is the Android window for the app, and this is the iOS window of the app. I'm using two different screen recording software so I can show this to you. So I'm gonna go ahead and replay the exercise. And there's a bug for the results screen that we're going to fix later. But what I'm also going to do is going to turn on the heavier computation model, our machine learning model. And the algorithm model that we're using is PostNet. It was made by TensorFlow, and we incorporated it into Unity. And I'm quite happy with the performance we've been having. All right. So what you're going to notice is that the Android app is going to chug a little bit more than the iOS app, which remind you is the bottom of the screen. And that is because there is a dedicated chip on the iPhone that is dedicated for machine learning in neural networks. So it's going to detect things better. Now, the algorithm I'm using is a lot stricter, so it might be a little bit harder to detect it. Okay, a lot harder to detect it, apparently. All right, so I'm going to go ahead and put it on the softer model. All right, okay. And so basically, it's just checking to see if you're lifting your legs above your waist. All right, and then arm cross is simply just crossing your arms. I'm going to do the same over here. All right. So I know it seemed like the iOS version of the app underperformed, but it's not really apple to apples comparison because I currently have this as the stand. But still, it shows that our app, it really does perform well on older devices. This is the iPhone 8 and Samsung Galaxy S9, which released back in 2018. So our target group, what we're looking for is people with a smart device. So we're happy to see that our app performs well and that we're going to be able to see how it does for these people.
It's very cool. Very cool. Way to go. Nice job. Okay, very nice job. Okay, so we'll go on to the next category. Thank you to all of REU. I mean, as a reminder, the REU is an optional program. These are students who signed up for something kind of in addition to their classwork. They maintained and managed all of this in addition to doing a lot of their classes. And so kudos to them for being able to balance all that and be so successful. Great job. Okay, so we'll move on to the next category. And I guess one other thing is for those listening, the REU program is something that we run every year. Look for an announcement next September if you're interested in doing undergraduate research sponsored by somebody on your faculty. Look out for that and work with them to to come up with a project topic and participate in that. We'd love to have more students involved in that. Okay, so we'll move on to our graduate award winners. Clearly you can see them there. Congratulations to these 3 students. Graduate students are, of course, more not groups. These are graduate students performing their PhD research or master's research under a faculty advisor. And so our first place award winner is from the IMSE department, mentored by Dr. Melanie Sattler. Excuse me, I think Melanie is CE, sorry, civil engineering. Her project is Multisorb, a low-cost approach to remove multiple metals and organics from leachate. I think that's right. So congratulations to Mithila Chakraborty, and we will turn it over to her.
Thank you, everyone. This is Mithila. I am a student of civil engineering with my major in sustainable solid waste management and engineering. My supervisor is Dr. Melanie Sattler. Thank you very much to all who liked my work. Last year also my project got the first place, and this time also, so I think I'm lucky. It's a project about removing multiple metals and organics from leachate. So usually there are several techniques through which we remove pollutants from the leachate, but among them adsorbents are one of the most important one, or I can say adsorbent works better. So our try is to remove those metals and organics from leachate by using the waste mid adsorber, and so far the results are very promising. Recently we did a batch test where we found that the results are similar to the commercial activated carbon whom we want to replace, because they are coming from coal, which is not renewable in human time scale. So if we can replace them with the waste, then we can get rid of the waste, as well as we are not using those coal resources as well. So there will be some more tests I will be doing in this year, and hopefully the result will be promising enough to at least reduce the burden on commercial activated carbon. So Dr. Melanie Sattler is my supervisor, and if I want to say something about her, then I will summarize that I always want to be like her. She has the level of patience, level of integrity, level of care to her students. It is I have never seen to anybody. So thank you to her. Thank you everybody who liked my work, and I hope next year we can do an in-person innovation day. Thank you.
Thank you, and we agree. Dr. Sattler is one in a million, and we're lucky to have her here on the faculty. We appreciate all she does with the students. Okay, for second place is a mechanical and aerospace engineering student, and he will talk about 2D mix compression inlet sizing of supersonic vehicles. It's a project advised by Dr. Bern Shadoba, and the winner is Jose Medina. Take it away, Jose.
You're muted, Jose.
Hello, can you hear me?
Yes.
Okay. So hello everyone, my name is Jose Medina, but I also go by Tini. I'm a Master of Science student and a graduate teaching assistant at UTA. I want to start off with thanking UTA and Dr. Wetz for hosting Innovation Day, especially during today's times. You give an opportunity for online students like me to visualize and summarize and appreciate the work we do here. My gratitude also extends to my research advisor, the director of the ABD lab, Dr. Bern Shadoba, and PhD lab partner, Hadin Kumar, for their invaluable mentorship. With Dr. Shadoba's guidance, and Hadin and I have been working on the development of a generic inlet sizing tool that pieces together the propulsion airframe integration during the conceptual design phase. What excites me about this work is how it ultimately contributes to the ABD lab's design capabilities, and recently the ABD lab has been working with the NASA and Langley on a feasibility study of hypersonic commercial transportation. I share my favorite hypersonic transports, the Orient Express that was introduced in 1926. It was awesome to see the same technology being developed by commercial companies such as Hermes. It is my goal through my research specifically applied for supersonic inlets, and that will ultimately be applied to hypersonic inlets to implement the lessons learned from the past design concepts to today's level of technology. What's interesting to see is how the design concepts are pretty similar, and if we can incorporate these in the conceptual design phase to an operational vehicle, that'd be amazing to see. Thank you.
Way to go, nice job and great work. We'll go back to the slide. So if you think maybe you stop sharing your screen, Dr. Igor can take over. Mr. Igor can take over. There we go. Okay, in third place is another electrical engineering student. I've had the privilege of working with Qazi Shaheed a lot and known to be a great student. We're very fortunate to have him in our department. He is advised by Dr. Yanis Skizis, and his project is unsupervised hyperspectral unmixing via nonlinear autoencoders. Take it away, Qazi. Congratulations.
Okay. Thank you, Dr. Wetz. I'm sorry the title of the project is a big mouthful. I'm sorry about that. So thank you, everybody. Thank you for this opportunity to bore you all with my work once again. So my work is with a special classification problem that deals with hyperspectral images. So I'll just give a quick crash course on my project. So what hyperspectral images are is basically a unique type of images. So when we think color images, we think red, green, blue, base color images. But if we want to incorporate that with shortwave infrared, as you can see here, long wave infrared, and basically take that wider spectrum and split it into hundreds of bands, as opposed to just having several bands, we have a lot of extra finer color information in these images. So think, for example, in military applications, camouflage can fool traditional color images, but with hyperspectral images, it's a much bigger challenge to fool them. Understanding, assessing, mitigating, and forecasting potential damage in the agricultural industry from disasters like floods, or volcanic activity, and so on. For space exploration, detecting sustainable life in maybe the surfaces of other planets. There's a whole lot of work being done with hyperspectral images with the DoD, the USDA, NASA, Air Force, Navy, and so on. So the thing is, with this unique property of hyperspectral images, we have a unique challenge, is that because we have so much extra information per pixel, the resolution of the images as a trade-off is lower. So when we had if we have a high-res image with multiple small objects, in a traditional high-res image, we can have pixels where each pixel contains one material, but because we have low resolution, we have small objects all clumped together per pixel. So we have mixtures in pixels, and we need to be able to separate the items in those mixtures to be able to tell what they are. And it's very challenging in my case because it's unsupervised. So I'm kind of separating mixtures, but I'm going in blind. I don't know what they are supposed to look like. So this is the autoencoder network that I built. The unique property is that because I'm dealing with a very interesting and very diverse problem, the layers that I've had to build, they are simply conventional layers in neural networks. They are simply not equipped to deal with the complexity of what I deal with. So basically all these layers that I built, they had to be built from the ground up. So they're built from scratch to accommodate the specific problems I had to deal with. And then to measure accuracy, I basically saw how much error I was getting in my performance results. So the lower, the better. And I had very challenging data sets to work with. It went from 0 decibel SNR to 20 decibel SNR, whereas conventional other competitive methods maybe will start from 25 or 30 decibel SNR. So basically you can see that the method, my method, which is in blue, significantly outperforms any other competitive schemes that are out there. So basically that was a brief overview of my work. Once again, everybody, thank you for this whole program, this opportunity to showcase my research work. Thank you very much. Have a great day, everybody.
Thank you, Qazi. Way to go. Great job. I know Dr. Skizis is proud of you as well. Okay, so we will move on to our senior design winners. Okay, so here are you can see the first, second, and third place winners there. We have three different departments represented. So we will start with a project that is advised by Dr. Fernandez in Mechanical and Aerospace Engineering titled Tube Cleaning Device. And that was performed by Samuel Law, Morgan Jones, Matthew DePalma, Enoch Maldonado, Colin Bednars, and again, Dr. Fernandez advised it, so I will let you take it away, Samuel.
Hi, thank you so much. First off, we would just like to say thank you guys. We are beyond blown away that you guys thought this worthy of the win. I'd like to say this is definitely a team project, so I'd like to thank all my team members and let you know what they look like on campus. We built this device for our senior design project, and the device looks something like this. If you want, you can go back and watch our video showing how it all works and some of the parts moving. The goal of the device is to clean test tubes in a renewable manner. So lots of labs use plastic test tubes instead of glass test tubes. Our device allows you to clean those without having to do a remodel and redo the whole, put in an industrial tube cleaning device. Industrial tube cleaning devices are large and expensive, whereas our device is designed to fit within a standard lab sink. Thank you guys so much. I did promise to be under the 2 minutes or the 3 minute mark, and I believe I have fulfilled that. And one more time, thank you so much to my team and to Dr. Fernandez, the UTA Fab Lab, and the UTA Machine Shop.
Very cool. Thank you, Samuel. Staying under time is something that will benefit you greatly when you graduate. We will go to our second place winner, which is titled Mars Rover Suspension Design. That is advised by Dr. Saibun Chwacha. And the students are Lisa Dakwar, Justin Beck, Ace Chowdhury, Nathan Wen, and Kyle Vargo.
Hi, thank you. I'm trying to share my screen real quick. Okay. So first of all, our team just wanted to say thank you for watching our video and everything. We're very proud of the work that we've put in, and we're very surprised so many people thought we did really well. We're very happy about that. I'm just giving you guys like a brief rundown. Our sponsor is the UTA Texas Rover team, and they came up to us last semester with a design issue with their 6-wheel rocker bogie design, which can be seen on the left. And basically they had an issue of roll up where one of the front legs would just kick up and hit the rest of the suspension. And that would just cause the Rover to tip over, and it would put them out of their competition. So we, after a lot of simulation and redesign of the whole system, we decided to switch to a 4-wheel rocker design. This saved on weight and cost for our client, and that was something that they really valued a lot. Here's the kind of the finished product of the Rover that we have. It was a lot of fun to drive around. We were able to take it out almost every weekend around the Metroplex or even around school. And it was definitely the most fun for our team, was just driving it. We had a few instances where we did have to run after it, but it was a really fun project. We have the video if you guys want to go take a look into it a little more, but we just wanted to, have like a moment to just thank Dr. Bowling, who was our faculty advisor, as well as the UTA Texas Rover team. They just provided a lot of advice and help for us, and we really thank them for everything that they did.
Way to go. It's very cool. Very nice looking. Somebody else who might be good at this robot competition. So I'm going to reach out to you as well. Be prepared. Okay, our third place team is one from the IMSE department, and that is, the project is Allen Ritchie Niagara Water Offloading Process Improvement. And that is, again, John Smith, amazing, somebody who was involved in both REU and senior design winners. So kudos to you being successful in both of those. Christina Wen, Abigail Werner, William Watt, and again, it was advised by Dr. Jamie Rogers. So I will let you take it away again, John.
Thanks, sir. I've had the opportunity this semester to be a part of some amazing teams, and this one was the senior design project. Thank you to our industry sponsors for being able to put this on. Again, without y'all, this would not be possible. And y'all within the College of Engineering. Our project is the Allen Ritchie Niagara Offloading Process Improvement, like he said. Our sponsor was Dr. Jamie Rogers, and she guided us through this project. A little bit of background on the project. Niagara Bottling is the largest privately owned bottling facility for bottled water in North America. They've got facilities across North Texas, the United States, and into Mexico. And Allen Ritchie is a locally owned and operated transportation company that delivers loads of spring water to Niagara to be offloaded and then bottled for our consumption. Right now, this is a picture here of how the trucks hook up and the trailers hook up to the pumps to unload the water into the facility. Currently, drivers are waiting somewhere between 30 minutes and 2 hours to begin the process of checking in the water and making sure that it's clear to drink and it's safe for our consumption. We use the DMAIC process to analyze this problem. It's the 5-step process, which is the gold standard in process improvement and industrial engineering. We defined our problem and looked at the current process, our problem being high driver wait times in the offloading area. We were able to set our goal to reduce it by 50%, and our current monthly costs going into this project, we had some data that we were able to set up and collect that was showing $1,500 to $4,000 per month was being paid in detention and wait time. We analyzed this process and the data and came up with a root cause and some potential issues being poor communication methods from outside to inside the facility and the visibility of the offloading area from inventory personnel that are inside of this facility. The facility measures over 1,000 feet long on one side and 400 feet long on the other side. It's a massive scale. So we looked to implement some solutions. We considered 4 different ones and weighed them against one another, and finally decided on a 2-way radio communication system that's used by the inventory personnel already. We're going to get Niagara drivers onto that system and have them be able to communicate directly with the facility when they arrive. We're going to control this process over time using a flowchart and continuous monitoring. Our issues were clearly laid out. We found the problems, and our implementation is currently in a pilot program this week, and we hope to have some meaningful data and hopefully improvement by the middle of next month. Once again, thank you to everybody that has come out today and made this whole opportunity possible. The IMSC department has put together some amazing teams.
Very cool. Thank you. And thank you to Dr. Rogers for mentoring there. Okay, we'll go to our next slide. So the last 2 awards we have are in a partnership with L3 Harris. Miss Violet Larson is representing L3 Harris, and she is in attendance, but due to some Teams problems is unable to present, so I'm going to do that on her behalf. But wanted to say a big shout out to L3 Harris. They've been amazing to work with ever since we started Innovation Day. They've been sponsors of their L3 Harris Link Innovation Awards, awarding a graduate and undergraduate winner each year. Their university rep, Miss Phyllis Calhoun, has just been a really big champion for us, and so many of their people over there have been amazing champions for us. So thank you to them. For those of you who don't know, they're right over here by the ballpark, so it's a great place to look at working for those of you looking for a job. I'm sure they're always looking to hire, and they do some amazing stuff over there. So their graduate winner is above the bin recyclable plastic detector. And these students we have not notified yet, so hopefully they are on and watching this, but we will reach out to them. We won't have a presentation from them now. But it is Nirakia, Kamkar, and Krul Bagat. I hope I didn't mess up their names. And it is advised by Dr. Susan Ferreira. And L3 in their comments said that the reason they chose that project was because it relates to their FOD prevention detection emphasis on all their simulators. So it was something they found a lot of innovation in as it related to their particular industry. So great job to that group. And the undergraduate winner was the ALS eye tracking app, and that was by Stephen Costs, Anthony Vardo, Ji Shu, and Kelly Lee, and that is advised by Dr. Christopher McMurrow over in the Computer Science and Engineering Department. So great job to them. And L3 said that this project is a new technology that would help pilots and instructors within the simulators. So again, found some great applications to how their projects, to those of you working on these projects, probably didn't even know all the different uses that it can be used in. So this was a great opportunity for industry to look at what you're doing and see how it applies to their work already. So congrats to them, and thanks again to L3 Harris for all their hard work in supporting us. And I think the next slide brings us to a conclusion. Again, I want to thank all of the student participants, all of the faculty advisors, all of the people in the College of Engineering who have helped to make this day possible throughout the year. It obviously is a year long in the making, and we will do it again next year. We're already looking at dates tentatively around the same week in April. We just haven't decided exactly which day, but we will put that out very soon, and we look to all the students and sponsors to help us again next year. So thanks again to everybody, and congratulations to all our winners and their advisors. So take care, everybody, be safe, and finish up the semester strong. Thanks.